Hi, welcome back to this channel. In this video, we are going to discuss chapter 7, which cover this objective from A until H. So the tutorial question that will be covered in this video is from question number 1 until question number 10. Let's start with tutorial question number 1. Write the definition for acid and base according to the Arrhenius theory and also Bronsted-Lowry theory. So according to the Arrhenius theory, acid is any substance that are going to produce H+, while base is any substance that produce OH negative when dissolved in water. According to the Bronsted-Lowry theory, acid is proton donor, while base is proton acceptor. Question number 2, H2PO4 negative is an amphoteric species. Write the equation to show that they can behave as acid and also base, and then identify the conjugate. So first equation as here, H2PO4 negative will form HPO4 2 negative. So from here we notice that proton is donated. So in this case, H2PO4 acts as the acid, while this HPO4 2 negative is the conjugate base. Next equation, H2PO4. Now we're going to pair with H3PO4, at where we notice that proton is gained by H2PO4 negative. So this case, H2PO4 acts as the base, while H3PO4 will be the conjugate acid. Question number 3, write an equation for dissociation of 0.1 molar HCl and 0.1 molar CH3COOH. So as we remember, the HCl is strong acid, while when we read the question, we can see there is Ka value given, so that we know CH3COOH is the weak acid. Next, we are going to determine the pH value for both solutions, and then we have to comment the answer. So let's start with the first part. We write the equation. Due to HCl is strong acid, so it will dissociate completely. One-way arrow or forward arrow is used to produce H+ and also Cl negative. So basically, we always will write the H2O above the arrow for the strong acid, while another equation for CH3COOH, which is the weak acid, we will dissolve them in water. The water will write in the chemical equation, and then we're going to use reversible arrow because CH3COOH only dissociate partially. So CH3COOH is the acid, so it will donate the proton, which is next to the oxygen, and become CH3COO negative aqueous plus H3O plus aqueous. So we have done for the first part. So next we are going to determine the pH for both solutions. So we start with the pH determination of pH for HCl solution first. So as we know, HCl is strong acid, one-way arrow, produce H+ and also Cl negative. So initially the concentration is 0.1 and there is no H+ and Cl negative. For the changes, because it is strong acid, so it will dissociate completely, minus 0.1 plus 0.1 plus 0.1. And then finally, there is no HCl solution, but concentration H+ is 0.1 and concentration of Cl negative is 0.1 as well. So the formula to determine the pH value is pH equal to negative log concentration H+. So negative log 0.1 will equal to 1. So this is the pH value for HCl. Okay, now continue with the determine the pH value for CH3COOH. React with water, reversible error, then produce CH3CO negative aqueous and H3O plus. So because this is weak acid, we are going to use ICE table. The concentration is the unit for this table. So initially 0.1, water we can ignore them, and then 0 and for CH3CO negative and H3O plus. Because this one is dissociate partially, we have no idea how many percent is dissociate, so minus x plus x plus x due to the ratio of the equation for all these species is 1 to 1. So at equilibrium, concentration CH3COH is 0.1 minus x, while CH3CO negative and H3O plus are x. So then based on the question gives us the Ka value, which is 1.8 exponent negative 5. So then we use concentration over reactant, which is x multiplied with x over 0.1 minus x. Due to Ka is very small, which is exponent negative 5 or less than negative 5 is very small, so 0.1 minus x will approximately equal to 0.1. So with very simple mathematics, so we will take 1.8 exponent negative 5 multiplied with 0.1 equal to x squared. So x is equal to plus minus 1.34 exponent negative 2 molar. Because of concentration never in the negative value, so we can say that concentration H3O plus equal to x, which also equal to 1.34 exponent negative 2 molar. Then now we can calculate the pH value for CH3COOH. Press the calculator, we will get the answer is 2.87. Okay, so done for the part of calculation. So next part, the question asks us to look for the difference between them. So as we know, HCl is strong acid, so they will possess greater concentration of the H+. So the higher the concentration, and then we notice the pH value is lower. So this is the conclusion that we can get from these two pH value, even though they have same concentration. But because of the difference of the degree of dissociation, make HCl produce higher concentration H+, while CH3COOH produce lower concentration H+, and because they have different pH value. Question 4. A sample of orange juice with the pH value 4.2. Then we need to calculate the concentration for H3O plus and also OH negative. So as we know, the formula for pH is always equal to negative log H plus. So in this case, we already have the pH value, which is 4.2. But then we have no idea what is the concentration of the H plus. So and then we anti-log the negative 4.2, then we will get the answer. Concentration H plus is 6.3 exponent negative 5 molar. Okay, the next one we can use the relationship between the concentration H plus and concentration OH negative is always equal to Kw. Okay, as we know, concentration Kw is a fixed value, which is the 1 exponent negative 4. So I can use 1 exponent negative 14 over concentration H plus, which is 6.3 exponent negative 5. Press the calculator. The concentration for the OH negative is 1.58 exponent negative 10 molar. Question 5. Calculate the mass of KOH needed to prepare 500 ml solution with the pH value of 11.2. So normally when we want to find the mass of KOH, we need to know the number of mole of KOH. And then due to the number of mole and the volume given here, we will able to determine the concentration of the KOH. So if we want to know the concentration of the KOH, we can relate to the concentration OH negative. With the pH value given here, because we know the relationship between pH and pOH is always equal to 14. So now we can determine the value for the pOH, which is 14 minus 11.2 equal to 2.80. When we have the pOH value, we relate it with the pH equal to negative log concentration OH negative. To determine the concentration OH negative, we are going to anti-log the negative 2.8, which will equal to 1.58 exponent negative 3 molar. Due to the KOH is a strong base and it is also a monoprotic base, so 1 mole of KOH will going to dissolve in water to produce 1 mole of K plus and also 1 mole of OH negative. So from here we will have the idea concentration OH negative that we determine over here 1.58 exponent negative 3 is equal to concentration of KOH. So then we press the calculator equal, and then we know that concentration is equal to number of mole of KOH over the volume of solution. So concentration that we calculate is 1.58 exponent negative 3. We have no idea the number of mole of KOH, but we know the volume given is 500 ml, but we need to convert them to liter, which is 0.5 liter. So then now we're able to calculate number of mole of KOH will equal to 7.9 exponent negative 4 mole. To determine the mass of KOH, we're going to use number of mole of KOH multiplied by the molar mass of KOH, which is 56.1, and then will equal to 4.43 exponent negative 2 gram. Question number 6. Benzoic acid is an organic compound which is widely used in food preservative. If a beaker is filled with 1.21 molar aqueous solution of benzoic acid, calculate the pH value. So since the Ka value is given, so we know that the benzoic acid is weak acid. And due to the Ka value, the exponent here is negative 5. So we need to do assumption. Before we continue with the working step, first we must always write down the equation. C6H5COOH equals dissolve in water, and then reversible arrow will produce C6H5COO negative equals plus H3O plus equals. Then we need to have ice table with the unit of concentration. Initial concentration for benzoic acid is 1.21. Water will be ignored. C6H5CO negative is 0, same as H3O plus. Then CH benzoic acid minus X plus X plus X. So at equilibrium is equal to X, 1.21 minus X. So step number 3, we are going to write the Ka expression. Concentration C6H5CO negative multiply with concentration H3O plus over concentration benzoic acid. Okay, water is not included because the phase is liquid. So now we substitute all the value in to the Ka expression. Okay, since Ka is very small, So 1.21 minus x will approximately equal to 1.21 as well. Then we put into the calculator 1.8 exponent negative 5 multiply with 1.21 equal to x squared. So x will equal to positive minus 8.87 exponent negative 3. Because of concentration H3O plus will equal to x, and then we always take the positive value, which is 8.87 exponent negative 3 molar. So using the formula pH equal to negative log concentration H3O plus, we will get the pH value 2.05. Proceed to question B. Now the question asks us to determine the concentration H3O plus, C6H5CO negative, C6H5COOH, and also OH negative. Since at the equilibrium row, concentration H3O plus will equal to concentration benzoate ion C6H5COO negative, which is equal to X, at where we already calculate in the part A, which is 8.87 exponent negative 3 molar. While at equilibrium, concentration C6H5COOH is equal to 1.21 minus X. So 1.21 minus 8.87 exponent negative 3, we will still get is around 1.20 molar. So last one is the concentration OH negative. So we are going to use the relationship concentration H plus multiply with concentration OH negative equal to 1 exponent negative 14. So concentration OH negative will equal to 1 exponent negative 14 divided with 8.87 exponent negative 3. End up we will get the final answer is 1.13 exponent negative 12 molar. Then now we are in the question C, the percentage of dissociation of the benzoic acid. So this one, as we discussed before, it is quite similar with the percentage of dissociation, which is equal to change over initial and then multiply by 100%. So change of concentration of benzoic acid is X, at where is 8.87 exponent negative 3. While initial concentration is 1.21, and then we multiply with 100%. Press the calculator, end up we get the answer is 0.73%. Question 7. An acid HX was found to have a pKa value 4.88, while pKa value for acetic acid is 4.74. Which one is stronger? So as we know, if pKa value higher, the Ka value will be smaller, and then the strength of the acidity is lower as well. So in this case, pKa value of HX is higher than acetic acid. Therefore, HX is weaker than acetic acid. So second part of the question, what is the value of the Ka for HS acid? So as we know, pH is equal to negative log concentration H plus. So pKa will equal to negative log Ka. So now we have the value of pKa, which is 4.88 equal to negative log Ka. So anti-log negative 4.88, we will get the Ka value is at 1.32 exponent negative 5. Question number 8. The degree of dissociation for 0.1 molar hydrazine is 0.36%. Calculate the Kb value. First, as usual, we need to write the equation. N2H4 equals dissolve in water to produce, because it is weak base, reversible arrow is used to produce N2H5 plus equals NOH negative. Since this is a weak base, so we are going to use ICE table. The concentration of the unit that we choose is mole per liter. Initial 0.1. Water, ignore them. Initial there is no OH negative and N2H5 plus as usual. So this time the changes is 0.1 times with 0.36%. which is equal to 3.6 exponent negative 4. So when we minus this, so the concentration for the N2H5 will be plus 3.6 exponent negative 4. This one OH negative, also similar case. So at equilibrium, 0.1 minus 3.6 exponent negative 4. So 3.6 exponent negative 4, 3.6 exponent negative 4. So next one, we will going to write the Kb expression. Concentration N2H5 plus multiply with OH negative divide by concentration N2H4. So substitute the value into the equilibrium row into the Kb expression. Press the calculator, you will get the answer is equal to 1.30 exponent negative 6. Question number 9. Calculate the concentration of pyridine, which means initial concentration, at where the pH value is 9.5 and the Kb value is 1.7 exponent negative 9. Due to the pH value is given, then we are able to determine the pOH value. So the pOH value is equal to 4.5. So with the pOH value, we are able to determine the concentration of OH negative. So the concentration of OH negative is 3.16 exponent negative 5 molar. And normally we know that the concentration of OH negative here is referred to the at equilibrium. Then now we have the Kb value. So we are able to write the Kb expression. So if you have no idea how to write the Kb expression, means that you need to write the formula, the dissociate equation, C5H5N equals plus H2O liquid, dissociate, produce C5H5 and H4 plus. NH plus. Normally, when we want to gain the proton, we will gain the proton next to the hydrogen. So C5H5 NH plus OH negative equals. So from here, we know that the Kb value is C5H5 NH plus multiplied with the concentration OH negative over the concentration C5H5NH. Okay, so if this is the ICE table, so initially we have no idea what is the initial concentration, but we know that we are going to minus 3.16 exponent negative 5. Water, ignore, and then here is 0 plus 3.16 exponent negative 5 plus 3.16 exponent negative 5. Why so? Because just now we just calculate over here the concentration of OH negative at equilibrium is 3.16 exponent negative 5. So here will be 3.16 exponent negative 5. This one also 3.16 exponent negative 5. While this one will be y minus 3.16 exponent negative 5. So substitute the KB value given over here is 1.7 exponent negative 9 given in the question over here equal to 3.16 exponent negative 5. Since both are the same, so we can simplify its square, and then over the initial concentration of pyridine we have no idea, so we may put a y value unknown in, and then minus 3.16 exponent negative 5. So press the calculator, you will get the y value, which is actually referred to concentration C5H5 and initial is equal to 0.587 molar. Question number 10. The neutralization is between a base and also acid will form a salt. So now we need to classify the salt and also predict the pH value using appropriate equation. So as we know, NaOH is strong base, while CH3COOH is weak acid. Therefore, the salt that produced will be considered as basic salt. So let us prove it. So NaOH react with CH3COOH going to produce CH3COONA plus H2O. Neutralization is an irreversible reaction, therefore one-way arrow is used. So the equation must include the physical state. So then the salt will going to dissociate CH3COONA, dissociate one-way arrow as well to produce CH3CONA negative equals plus Na plus equals. So due to CH3COO negative is from weak acid, therefore itself is a strong conjugate base, at where it will able to break down the water to form CH3COOH plus OH negative. While for the strong conjugate, while for the other one, which is the Na plus, it is from strong base, so therefore itself is a weak conjugate, and when react with water there is considered like no reaction. With the presence of OH negative, so we know that the pH value of the salt solution will more than 7. Question B. HBr is strong acid, while NH3 is weak base. So basically, the salt that produced will be considered as acidic salt. So if it is acidic salt, when we write the equation, we will able to see concentration H plus is produced. Now let's check the equation. HBr react with NH3, we will going to get NH4Br. So NH4Br, when dissociate, it will produce NH4 plus Br negative. So NH4 plus is from the weak base, so itself is strong conjugate, which is able to break down the water to produce NH3 and also H3O+. With the presence of H3O+, so we know that the pH value will less than 7. While Br negative is from strong base, so itself is a weak conjugate. And then it will not able to hydrolyze the water, so no reaction. Last question for this video. KOH is strong base, HCl is strong acid. So when both of them react, they are going to produce neutral salt. So if they produce neutral salt, the pH value will equal to 7. So KOH plus HCl going to produce KCl plus water. So when KCl dissociate, it will produce K plus and Cl negative. K plus is from strong base, so it is weak conjugate. And it is not able to hydrolyze the water, so no reaction. Same case happened to the Cl negative. It is also weak conjugate because it is from strong acid. So react with water also no, cannot hydrolyze water, so we consider there is no reaction. So in this case, concentration H plus and OH negative are not produced, so the pH value will equal to 7. Okay, we are coming to the end of this video. So this final slide will show you the final answer for question 2 until question 10. Thank you for watching this video. We will continue buffer solution in next video.